Let's talk about artificial intelligence. There are two different ways to do AI. First, symbolic, and second, subsymbolic. Symbolic means you define rules and statements, and by that you are trying to derive new knowledge out of it. Subsymbolic is more that you try to build up systems which are trained and where you do not have clearly specified rules. What have been typical problems and test cases? For symbolic AI, very much things have been used like playing chess or playing games in principle, because here you have these clear rules, you have statements, which is, for example, a certain position in the chess game, and you can from that derive what are possible next moves and so on and so on. For subsymbolic AI, typical test cases have been translation and image recognition. The problem has been from the very beginning that some subsymbolic AI is a little bit more complex in two dimensions. First, it requires much more computer power, which hasn't been available in the 50s, but not even in the 90s. And in addition, it's very hard to think that way. Typical people from AI came from mathematics, and they are used to work with rules and statements, so symbolic AI seems to be closer. If you take a look at this game Akinator, which is a simple game, just give it a try. You have to think about a person, and then the Akinator asks questions which you can answer with yes or no, and by that, as an Akinator tries to find out who is the person you're thinking about, and usually he will come up with a good result. In this game, you have simple datas and rules. So the data is all the people you remember, which are stored in the system, and the rules are the question which always classify the two groups in yes or no. Where are the borders of these kind of expert systems? Yeah, that's quite hard. If you, for example, take translation, then it is very hard to define rules for translating. Yes, you can say that a certain word in English corresponds to a certain word in German, but there is often some kind of meanings, there is exemptions, and so on and so on. So it's really hard to really have clear rules and to be specified. Same for image recognition. Simply try to specify rules which, for example, are used to specify if on a certain picture there is a person or a face of a person. So these kind of rules have their limitations. Now, what is the difference between machine learning approaches and rule-based approaches? When you have these rule-based approaches, you have to define the rules by yourself. By machine learning, it's the other way around. You're, let's say, on a higher abstract level. You define the way forward, but you do not define rules. You basically give lots of inputs, the training material, and define what is right and what is wrong. For example, where is a face, where is no face on the picture. And then the system, the machine learning system, tries to somehow, and this somehow is really some kind of vague from people, try to somehow define rules and uses the rules later on if pictures are shown which are not classified yet.